So good morning everyone. I welcome you all for this AI webinar on robotics. And in this webinar, we will be seeing some of the concepts and some of the basic topics that you need to know regarding your artificial intelligence. And we will see some of the real-time examples so that you may get an idea what is an AI and how and all AI is being embedded with us. Okay. So based on the examples I'm just going to give, you'll get an idea. Okay. So what are the different kinds of applications are using AI? Okay. So AI is nothing but artificial intelligence. So in this webinar, as I said, the topics as well as the examples will just give you some of the basic knowledge on this topic AI, and also we will see some basic code on training a model. Okay, I'm not going to just full-fledged, I'm not going to run that model, but I'll just show the some of the basic code so that how to train some basic models. Okay. Okay, let's start with the normal concept of AI. So it is nothing but an artificial intelligence. Yes. So we are giving some intelligence to that artificially made thing. Okay. So we human, okay, we have some intelligence and we are created by the nature, right? So the same intelligence. So what are the intelligence we are having? So we are providing to a machine such that it is able to think and it is able to perform its operations automatically. So that is the exact concept of implementing your AI. So making some of the machines to work autonomously and getting some or analyzing some data and predicting the future output, or we can say like predicting some of the future analysis, future scope, okay, of certain actions. Okay. So for these kinds of things, nowadays we are using artificial intelligence. Yes. So we will just go one by one. So we will see what is an AI, and in this webinar we'll be first starting with the introduction of your AI, and then we'll see some of the types of AI that are available, and followed by the types of AI agent. Okay, I will explain what is an AI agent and how many types are there, and we will see what is an agent and what are the platforms that you are using for this AI application, right? So we'll start with AI. What is an AI actually? Why it is nowadays we are everywhere we are able to hear this topic AI, right? So wherever we go, so whatever the papers that publishes some of the blooming technologies, so in that articles or papers you are noting this point or noting this concept like AI. Okay. So why AI is very much popular today? Can you might have some ideas. So why AI is very much popular is that, so nowadays we are generating lots of data. Okay, so just 10 year or 15 years back, so most of us don't have some kind of advanced smart devices. Okay, so whatever the devices that we have before the past 15 years, they are all some conventional. Okay, they are manufactured for doing some specific task. For example, I can say your previous mobile phone. So in previous mobile phone, only you can able to do some SMS text and you can just able to call, right? But now we are using some smartphones where we are using that smartphone as a computer. So now it acts as a general purpose computer. So before, the mobile phones are under the category of your embedded system, so which is going to do some specific task. But now your smartphones are not under that embedded system. It is now just comes to the topic under of general purpose system. Okay, using your smartphone we can do whatever the things you are able to do with your laptop or desktop, you are able to perform it with your smartphone. Yes. So that's what is the key point for making artificial intelligence to bloom in this 2020 or 21 years. Okay, so as I said, we are generating some data, right? Yes. So whatever the or whenever we use some of the smart devices, we are either consuming some data and we are also sending some data. Okay. So what the data exactly acts? Okay. We are always saying that our data it is being traced or tracked. okay, or it has been analyzed. So what is the data? So data is nothing but it's a collection of some useful information. Okay, so that information might be varying based on the applications, or might on the based on the analysis. Okay, so based on the task of the analysis you are going to perform, the type of data you extract varies. Okay, so for example, I can just give you an example on a smartphone, your smartphone mobile app. So nowadays, some youngsters are using the mobile app for counting their steps and for counting their calories. Okay, so how much of calories today I have burned? Okay, I think most of the youngsters who are working out are having this kind of apps. So how that kind of apps know whether we are walking and at what speed we are walking? Yes, so these kind of apps requires some data. Okay, so after you downloaded that application in your mobile phone, yes, the app access your mobile phones, some of the sensors that are available in your smartphones. For example, I can say some accelerometers, GPS locations, and using that accelerometer we are able to find the acceleration of your moving object, or the acceleration of a person. Okay, so based on the moving action of the mobile phone, and also by using the gyroscope of the mobile phone, we are able to track that whether a person is moving. Okay, either he is walking or he is moving in some kind of vehicles. Yes, so based on the speed and the motion of his hand. Okay, so while we are walking, our hand motion or you can just measure that our hand motion from the gyroscope data. Okay, so by measuring different kinds of or by analyzing different kinds of data that are given by different kinds of sensors, so we are able to predict a kind of movement, whether the person is walking or sitting or is going or is moving in a bike. Okay, so we are able to classify it, right? So these kind of things are done with the help of your AI. Okay, we are analyzing some data and we are finding for some prediction, which is mostly an accurate one, right? As I said, nowadays we are using AI in most of the software applications, and also we are implementing in some of the hardware applications also, like a robotics or self-autonomous car. I can just give it as an example. Yes, so in the future it is more evolving in artificial intelligence, where your artificial intelligence, it is not a single topic. Okay, it is a group of subtopics. Okay, it has multiple kind of subtopics inside it, and it is still in the evolving stage. It is not under complete evolve, it is still in the evolution stage. Okay, so what the experts predict is that, so by implementation or by the evolution of the artificial intelligence, so they predict that, so whatever the technology that we are developed in the past 300 years, we will just replace them with the new technologies in the forthcoming 20 years. Okay, you can see that ratio between the past and the future years. Okay, it is very much you can, from that itself you can just predict that how faster the AI applications are growing, right? And even your this kind of applications are nowadays used in many kind of space kind of applications. Okay, where we are giving some intelligence to the robotics that are monitoring some of the unknown environment in your space and giving some data related to that environment. Yes, and we are able to provide a power or thinking power that which a normal human cannot have. Okay, a normal human cannot do some complex mathematical calculations in his mind. Yes, so we require some additional devices for doing some mathematical computations, but by giving some intelligence to a machine, I can make that machine to do some complex task. Okay, I can just make it to predict some data, and I can just make it to control something. So that is what your AI exactly does. So you can see our evolution, like our evolution has started from the monkey. Yes, so we believe that, and after that we are able to civilize the location, and we form a culture, and we formed a nation, and we unitedly in a social culture we are together and working for our task. Yes, And you can see that now technology, as per the technology evolution, so previous we have conventional machines, and after that now we are having smart devices, and now we are evolving in the field of brain computing devices, okay, brain control devices. So by using some brainwave sensors, we are nowadays we are doing some projects on detecting and controlling some of the home appliances or industrial applications. Okay, for differently able persons, these kind of brain control devices are very much useful. Okay, so for a patient who cannot move their head or hands or legs, can use this kind of brainwave sensors. Okay, so for controlling different kinds of applications by without moving, okay, without doing some actions. Yes, so these kind of brainwave controlled things are under development. Yes, and the next stage is your prosthetic limbs that are controlled by your brain signals. So in this prosthetic limbs, so in the previous example I said that we are using some brainwave sensors. Okay, so that sensors will be just having in our head, and that sensor will read some of these signals from our brain. Okay, so from our brain it is reading some signals, and based on that it is going to do some control activities. Whereas in your prosthetic limbs, we will be directly connecting our brain with a chip. So you know that you recently might notice that Tesla has found and they have just placed a chip in some kind of animal, right? And they have announced that they are able to successfully place that chip, and they are able to successfully communicate or get the signals from them particular animal, right? So in that way we are able to combine a biological matter with an electronical matter. Okay, right? So previous conventional we have pure electronics, so which we cannot utilize with a direct biological content. Yes, but nowadays we are creating some electronics, okay, and we are able to place inside in our body itself. So we are integrating, we are finding a chip and we are integrating with our brain such that, so whatever the signals that are sent to our body, legs, arms and whatever, okay, we are able to get that signal, and we are using that signal for controlling the same operations. For example, so what is the actual meaning of prosthetic limbs is that we are giving or we are manufacturing an armor like thing, okay, and we are the humans are going to wear that armor, okay, and by from that brain sensor or the brain chip, okay, some of the signals that are sent to your arms and legs are detected, and those signals are replicated and sent to the armor which you wear. Okay, so when you do some actions in your hand, the same actions will be done by the armor also. Okay, so by using this prosthetic limbs, I can just give supernatural power for the human. So if I just say we are using prosthetic arms, then I can make the human to carry a load of 300 kilos. Okay, without any strain, I can make that human to carry 300 kilos. Yes, so a normal human being can't do this kind of activities. So nowadays in military based applications, we are under research. Even DRDO is under the research kind of thing in analyzing these kind of prosthetic limbs. Already US has developed some kind of projects, and they have been testing with their military base on implementing this in the or adding this kind of technology in their military. Okay, so now we are under the development where US has already accomplished that. Okay, so this is how your prosthetic limbs work, and the ultimate final thing is your autonomous or the humanoid robots, which is similar like your human. Okay, so we will be using humanoid robots in place of normal humans, where we require, like I said, multiple mathematical computations when you just require to do, and some of the environments where you need some robotics. So for example, in this COVID situations, we now you may just notice some of the news that we are using some kind of robotics for sanitize the area, okay, and for serving the patients, right? And in place in this kind of unknown situations, you can use this kind of robotics. Yes, so in this kind of pandemic situations, we can use this kind of humanoid robots to serve us. Okay, so this is how your evaluation is coming on. Okay, so we are still under the development of brain based communications only. So we are still under the development of creating a humanoid robots. So as I said, artificial intelligence is a new technology which is going to take over all the things. Yes. Then how your artificial intelligence going to work? So for an algorithm to work, we have to give some data, right? So similarly, just a minute. So similarly, like if you want to drive a car, you require some petrol for running that car, right? So for running an AI application, what you require is a data set. So data set is the ultimate tool, or I can call it as an oil for my AI application. Okay, without data set, this AI application is nothing. Okay, so data set is the main thing for creating any kind of AI applications. Okay, so when I say an AI application, you know that machine learning, deep learning are all the subset of this AI. Okay, whereas what is the basic difference between your machine learning and deep learning is that everything as it is going to be run on the data set. Okay, your machine learning will just predict some useful information from the given data. Okay, whereas your deep learning, it is predicting the useful information from the data. Okay, and it is implementing in the real time, and when it encounters some kind of errors, then it automatically learns that. Okay, it automatically learns from that error, and next time it corrects that. Okay, it is learning in the real time also, whereas your machine learning can't do that. Okay, it is able to predicting some values whatever the data we feed. Okay, so this is your basic difference between machine learning and deep learning, right? So we'll come to the data part. So as I said, we are generating some data, right? So whenever we use some kind of like now we are all using our smartphones. So from the smartphone itself, we are lots of data are being traceable. Okay, so what kind of websites you are seeing, it is all traceable by your IP provider. Yes, and even so when you just move to a location, okay, it is also traceable. Your GPS locations are being traced. Okay, and even when you are using some kind of Google applications like your Google Maps, and you may have noticed that when you are moving to a particular area, so your Google Map will just recommend like you just go and visit this kind of restaurants or mall. Okay, whatever that is nearby you. Okay, some of the famous places that are nearby you. Okay, and it will also ask that if you are in this location, and have you visited this kind of places, or have you visited this restaurant? Okay, if you are visited, just rate it. Okay, it is asking for rating that restaurant. Okay, but how your Google app know you are at that particular location and that particular restaurant is nearby you, right? So this is how your data is doing magic. Okay, so based on the data, your smartphone anytime it is sending some data to the respective IP providers. Okay, and they are analyzing the data, and they are enhancing their services. Yes, for example, I can just give another example on YouTube. Whereas you will be searching, or whatever the videos you see in the recommend list some of the videos which are related to the videos you are seeing now. Okay, the content are all got related. Okay, so YouTube just does some analysis. Okay, it analyzes what kind of videos you are watching and what is your requirement, and based on your requirement, it is recommending some videos for you, so that it is making you to use YouTube website more. Okay, so that generates more kind of income for that company. Okay, so this is how AI is being used by the industries. Okay, so how this data is going to be transferred? I said that even every smart devices are generating data. Yes, so how these data are connected? So it is connected by a technology called IoT. Okay, I also said previously that AI is not a single topic, it is a combination, or it contains multiple topics, right? So the one topic that is under this AI, it's IoT. Okay, so what are the smart devices that we use in real time? It may be an Alexa or Google Assistant, whatever. Okay, it uses internet for communication. So nowadays in our home we are having like smart AC, smart fans, smart TV, Okay, we are able to communicate with that smart devices by either via your Alexa or by using some smartphones. Yes, so this is all happening by using the IoT applications. Okay, so through IoT application, I can just get some data from the sensors. Okay, and I am able to do some analysis in the cloud, and after that I am able to do some controllable actions for some kind of devices that are connected to the internet. Okay, so by IoT acts like a nerve system for our AI application that transfers different data from different parts and analyzes different data. Yes, so we have seen that data is our like a oil thing, and IoT acts like a nerve system for our AI application. So these two main topics are very much important for running an AI application. So this is your exact timeline of your AI development. So you can see that AI has been proposed in the year of 1950 itself. Okay, so in the year of 1950 itself, they have thought to implement a machine with some kind of intelligence. Okay, so they have tried to implement some of the basic tricks what human do. So they have just tried to implement in a machine and to perform the same thing, right? And after 1950, certain developments are continuously existed, such that in 1955 1961 they are completely using this kind of AI topics, such that they are converting the conventional human operated things into a machine operated things. Okay, whereas in conventional 10 humans are required to perform a single task, whereas a machine can do more number of tasks than a human. Okay, where only a single human is enough for operating or for monitoring that particular machine. Yes, so that's how your technology grows in AI. And in the year of 1966, they are able to create a simple autonomous robot with some basic movements. Okay, like a hand movement, like picking some product and placing in some point. Okay, so these kind of basic things are proposed in the year of 1966, and after the year of 1997, so the development was blooming in a more exponential rate. Yes, so in previous things or in the previous years, they have developed some kind of intelligence where they provide the data and it analyzes it and it does some task. Okay, so that was the exact working of the previous concept. Whereas after the year of 1997 and 1998, so what were proposed by AI application is that, so we are started to develop some kind of specially parts or the some parts of the human body. So we developed some legs of our human and we replicated the movements of human to the legs. Okay, and we created arms. Okay, robotic arms. Okay, and we created a robotic face. Okay, so that can do some or that can replicate our facial expressions. Yes, and we also developed some kind of robots that can mimic the animal nature, like dog, cat. So you have seen some of the robots, right? And in 2002 we proposed, okay, AI has been used in a complete autonomous robot. Okay, we call that robot name as a Roomba, so which is a vacuum cleaner robot. So actually we use this kind of vacuum cleaner robot for navigating inside a closed environment like our home. Okay, and it is useful for cleaning the dirt autonomously. Okay, it is able to locate the environment of that particular indoor location, and it is able to sense whether there is a human presence inside that room. Okay, and the robot it itself plans that path and it performs the cleaning operation without disturbing the humans. Okay, so it was the ultimate first autonomous robot that was implemented real-time application. Okay, that was released as a product. Yes, and after the for coming years, many kind of developments were done where different kinds of robotic arms and joystick control robots were all developed. Okay, and in the year of 2014 and 15, so we started to develop some of the humanoid robots, and in the 2016 we are able to create a robot called Sophia, so which replicates some of the actions of our human, and it is able to communicate with a human like a normal human being. Okay, the voice of the robot it is also similar like a human being. You cannot identify from the voice that it is a robot. Okay, in previous 1990s or sometime, so you can easily identify the voice that is created by a human than the natural human voice. Okay, but nowadays we are not able to identify that. Even our Alexa itself, it is able to communicate with a human in a normal human voice, right? It is able to call some persons. Okay, so these are the things, or the development or the evolution timeline of your AI application, right? So why we require to implement this artificial intelligence? So as I said, we require this AI for enhancing our services. Now, for example, let us consider an AC manufacturing company. Okay, so we are manufacturing AC. Okay, and we are distributing that kind of ACs to the local market, and from that our customers are buying our AC, right? So as a industrial, I want to know the particular requirement. Okay, so what is the requirement of my product? Okay, I have to plan for my future expansion, whether I have to increase the production or I have to reduce the production. Yes, so and I want to know how my customers feel on my product. They are happy with my product, or they are is there any discomfort, so that I can just modify the existing one and I can release a new version. Okay, so these kind of things are required for an industry for enhancing their products. Yes, so in this kind of thing we are using nowadays AI application. Nowadays whatever the ACs we are manufacturing, we are adding with a smart application along with it. Okay, so with that smart application, now I am able to track what are all the distributors are having or selling my AC. Okay, and who are all the customers are buying my AC. I can just get their list. Okay, by these kind of smart applications, and these kind of smart applications just sends the data to the industries. Okay, so when they have been bought by the customer and when they are installed, so what is the exact running or working time? Okay, so how long they are in the working stages? Okay, how many years has been passed? So what kind of services they require? So when you are using like a AC machine, then you have to do some services, right? Some 6-month service or 1-year service, right? So the company knows that this customer requires this kind of services, so automatically their service team calls the particular customer and they ask for that. Yes, so that your industry, it is now able to increase their production rate, and also the customers also feel happy regarding the support for that particular product. So like this you can implement AI in multiple product manufacturing. Yes, this is a simple example. Okay, so like this you can implement this AI in multiple products. So what is the ultimate goal of our artificial intelligence is that, so the ultimate aim it is to replicate the human knowledge. Okay, so how you think the same intelligence must be transferred to the application, right? And for completing some complex mathematical task, as I said, and to read some of the unknown environments. Okay, so for reading and scanning the unknown environment, we require an AI application. And for creating an autonomous robots, so which can learn by itself. So these things are the goals of your AI application. So as I said, AI consists of different kinds of field, right? So these are some of the field that are playing a role in your AI topic. Okay, so you can see the screen, like we have philosophy, computer science, psychology, neuron science, biology, mathematics, sociology. So these are some of the departments. Okay, and still more is there, so I've just given some of them. So you can see here, even philosophy and psychology, biology, it is not related to your electronics or engineering courses, but these things are also involved in AI. So when I create an robotics, okay, when I create a humanoid robot which is similar like a human, so that robot must know about our culture, right? So it must know about the human mentality. Okay, so how he feels in this kind of situations, whether he feels angry or sad, right? And it has to know some of the biological matters. Okay, it has to know about the nature, right? And it has to know about the sociology of the human. So how so human is a social being, right? So it has to know about that. And similarly, as I said, your AI, it is nothing but it is similar like your brain, where it has many number of neurons. Okay, so these kind of neurons have it transfers multiple number of datas. Okay, so based on the application. Okay, so this involves neuron science also. Yes, so different kinds of fields are involving. Okay, you cannot say that AI comes under this particular department. Okay, you cannot bound a circle for AI. It is present in different most kind of all kind of departments. So what are the applications of AI? So previously I have said many kind of applications, and even we are using this AI in online advertising. Okay, so based on the product you search in your Amazon or Flipkart, so the same product you can see in some other website which is not related to this kind of a product selling. Okay, so in that website also you are seeing some ads that are related to the product you have searched in the Amazon or website or a Flipkart. Okay, so they are just increasing the production rate as well as the consumable rate of the consumer. Okay, by continuously showing some ads, they are just showing that these products are available at this cheap rate. Okay, so one day or the other day you are going to book that. Okay, so for that this kind of applications of AI are very much useful, and we are using in some of the online applications we use, even Facebooks, right, and in stock market analysis and in web designings. So most of the applications are nowadays converted into an AI application. Okay, it is still in the evaluation stage. So we'll come to the main topic of robotics. Okay, so robotics, it is a huge topic, and AI, it is another huge topic. So these two multiple topics are combined to give a new topic called AI and robotics, right? So a robotic, which is nothing but a machine that going to do some repetitive task. So this was the definition for a robotics in the past 15 years. But now, along with AI, now you cannot say that your robot is capable of only doing some specific task or some repetitive task. Now nowadays our robotics or the developed robotics are able to do some actions which we cannot do. Okay, it does this operations similar to your human being, and which also cannot done by a human being. Yes, so this AI gives additional power for the robotics. So as said an example, right, Sophia robot, so it is able to communicate like a human. So it is able to communicate with some other person through some of the mobile networks. Okay, it is communicating with a smartphone, and the other side, normal person, he cannot identify that the speaker from the other side, it is a robot. He cannot identify that it is a robot. It is just thinking that it is a normal human. Some other human is speaking to him. Okay, so that in that wise our performance of implementing an AI in robotics has been developed. Okay, and we also interfaced vision based systems for our robotics. Yes, so nowadays in this 2020 year, so most of the projects or the engineering projects we are doing under the machine vision based projects. So we are doing some face recognition based applications, like face recognition based object tracking. Okay, or face recognition based authentications. Okay, or vision based navigation. So different kind of applications are we are developing using this machine vision. Okay, so whenever we have to create a humanoid robot, it needs some vision. Okay, it needs some mic for hearing the voices, and it needs some kind of speakers for communicating with the human, right? So machine vision nowadays plays an important role. Okay, so even in our security cameras, we are able to, normal security cameras are able to only record. So nowadays we are enhancing that such that it is able to identify the owner of that house and also the intruder. Okay, and any thief or whoever entering the house in a illegal manner. Okay, it is able to identify that, and it is able to communicate with the respective authorities or the respective owners. Okay, nowadays we are able to develop these kind of applications using the machine vision. So these are all developed with the help of your AI. Without AI, these cannot be done, right? So as I said, speech recognition. So for this, I can just give an example on Alexa. Okay, your Alexa knows what you are going to ask. Okay, and suppose if I'm just going to ask my Alexa to play some music, it knows what kind of music I will hear, and it will just modify the playlist according to the music I regularly listen. Yes, and similarly, Alexa also communicates with me in a normal human voice. Okay, and it is also collecting some data which I want. Yes, and it is also doing some voice dialing. So it is also calling some persons. When I just ask Alexa to call some persons, it is calling someone. Okay, so these are some of the applications in our speech recognition. Yes. So we will come to the next part of our types of artificial intelligence. Okay, so we have two categories. So the type 1 category relates to our narrow and general and strong AI. So what is this type 1 is that? So how intense we are applying this AI application. Okay, so for a normal website, for example, for YouTube, for just analyzing the data and for showing the recommended videos, we either require a general AI or a narrow AI. It is the amount of intelligence you are going to use for the particular application. Okay, whereas for an autonomous learning class, you require multiple intelligence. Okay, you have to sense multiple sensors and multiple you have to perceive different kind of, right? And even for your human robots, you have to sense multiple things. So where we involve or we apply a strong intelligence in those kind of applications. Okay, so based on the intensity of application, we are classifying that we are classifying as narrow, general, and strong. And similarly, your type 2, it has some classification as reactive machines, limited theory, and theory of mind, self-awareness. So as I said, this is all belongs to your type 1. So you can see in the image, right? So there are some examples related to your weaker or narrow A and your strong A, right? So some of the trip planning, yes, and your navigation, your routing. So these are all things comes under your narrow A application, whereas your strong A. So as I said, some of the autonomous cars and autonomous learning machines. So those things are coming under your strong A. So in the type 2, as I said, we have reactive machines. So what is reactive machine is that? So these are some of the machines that are going to sense some data and it is going to do some work. Okay, so based on the sensing data, we will be just define some of the controls. Okay, control actions. So if the data is like this, just perform the action. Okay, so based on the action only, it is going to react. Okay, so I can say like a machine which replicates the normal movement of a human or a robotic arm. Okay, which replicates the same action. Okay, so nowadays we are getting the robotic arms in a teach mode where we can just teach that robotic arm on what kind of operation we require to do. Like if I'm just going to use it for pick and place, I will just teach once for picking and placing. Okay, and after that it is able to do that same operation multiple times. Okay, and we have another topic under like limited memory. Yes, so where we give or we provide the intelligence for this kind of missions. Okay, for just predicting some kind of details. Okay, and in theory of mind, we are providing some more intelligence such that your Roomba autonomous robot we have discussed earlier, right? So this kind of robots come under this third category, where it has a knowledge of sensing that their environment, sensing the human presence inside that room, and it is able to optimize its path. Yes, and your self-awareness. So your Roomba model, it is able to do only some kind of cleaning work. Okay, it cannot do some other different task. Whereas your self-awareness, whatever the things that are coming under this category, self-awareness, so it is able to do multiple tasking. Okay, so multiple tasking means, for example, this humanoid robots can talk to us, can react, can do some actions, and it can walk. Okay, so we have different kind of applications, right? So these things are all coming under the self-awareness. Okay, so we'll come to the types of AI agent. So before that, what is an agent? So we call a thing called agent. So whichever things are used for sensing and for controlling, like actuators and sensors. We call them as an agent. Now if you consider the human body, we have agents like eyes, ears and other organs. Okay, even our skin, it is also coming under this agent. Okay, we are able to sense, visualize the environment surrounding us. We are able to hear the sound. Okay, so if I'm just walking in a straight or in a road, I'm able to visualize the path. Okay, what kind of obstacles are there, and using my ear I can just I'm just watching for any kind of noises. Okay, so that it can alert me. Okay, and even my skin, so when I'm just moving, even from my skin itself I can just able to sense at what speed I'm moving. Okay, so when I'm moving fast, okay, so the I can feel at what speed I'm moving. Okay, these things are the sensors, or it is like a sensor for human for sensing that particular environment where he is. Okay, and based on that particular data now we have got from that eyes, ears and other kind of organs. So now I'm just, my brain, it is going to do some computation, and it is sending some signals to our hand and legs, such that you have to just move in this direction, or there is obstacle nearby, so just take some just change your path. Okay, so these kind of things are done by your brain. Okay, in the similar way, in robotics also we have sensors like cameras, infrared, okay, and your gyroscope sensors, and multiple sensors you are having for sensing different kind of environments. And as actuators you have motors. Okay, it can be a locomotion based motor, like you may have wheels for your robot, or legs, walkable legs. Okay, even that legs also, it has multiple types like biped legs, and even Boston Dynamics, you can just refer them. So they have created multiple different kinds of robots, okay, with different structures. Even the walkable robot, it is coming in different kind of structures. Okay, if you have time you can just refer this Boston Dynamics. So they have multiple different kind of format, and they have created multiple application of robots. Okay, you try to refer them for getting a good idea of about that. Okay, so now we will just come to the types of AI agent. So now we have previously seen what is an agent, right? So we have multiple types under it. So simple reflex, model based, goal based, utility, learning agent. So these are the 5 types we have. So we will see that one by one. So simple reflex agent, right? So as I said, an agent is nothing but it is going to sense and it is going to perform, right? A simple reflex agent, it is same like your simple application where it is going to sense some, it is going to get some data. Like if your AC means, for example, you consider your smart AC. Okay, the temperature sensor, it is going to sense the temperature of your room. Okay, based on the inputted temperature, your AC machine has some kind of control flow actions. Okay, if your temperature it is very much minimum than the temperature is set, then your AC machine is going to be turned off, or otherwise if the temperature is still it is in maximum than the set temperature, then we are increasing the performance of that machine. Yes, so these kind of things are coming under your simple reflex agent. Okay, it is not going to depend on the past data. Okay, it is going to sense the data at the current time, and it is going to do the action for that particular current time. Okay, it doesn't consider about the data of the previous past. Okay, so now next is your model based reflex agent. So it is similar to the simplex reflex, whereas this considers the previous data also. Okay, so this kind of applications considers our previous kind of data. Okay, it compares the previous data and the current state data. Okay, and it tries to get some prediction. Okay, like predicting the like predicting the motion of a human walking. Yes, so in a for a autonomous car, you can just pick a single application that it has the capability of sensing the dynamic objects that are moving. Okay, so when I say dynamic objects, they are continuously in motion. Okay, so to find the exact future point, Okay, I want to know about the current state as well as this previous path. Okay, so I from the past and current state I am able to track their motion so that I can predict their future point. Okay, so this person it is traveling in this direction at this velocity, so at this particular time after 5 seconds he will be in this location. I am able to track that. Okay, so like this kind of application using that past and current data are all coming under this model based reflex agent, and this is your goal based agent. So that Roomba autonomous robot are coming in this category, where instead of normal cleaning process, now if I just assume that I have set a navigation goal for my Roomba. Okay, so I have asked my Roomba model to move from the kitchen part to the hall room. Okay, so I'm just setting the navigation point or the goal point, and now the robot is an environment which it doesn't know about that kind of particular environment, right? So it uses some sensors to detect and to perceive the surrounding environment. Okay, it is able to visualize, and it follows like it knows only the starting point and the end goal navigation point, right? Okay, so now by just sensing the data, it is moving in some direction. Okay, now again it is sensing the new data, and it is also correlating that new data with the past data. Okay, it finds some kind of function, okay, that relates both the state, and from that it determines that whether it is moving in a right direction, and it optimizes the movement. Okay, so from the starting point to the end point, so it finds a optimized path. It is not going to take a long route for attaining the goal, so it takes some short route such that the reaching time is minimal, and it is also free of obstacles. Okay, so this kind of Roomba vacuum cleaner robots are coming under this kind of goal based agents. They have a particular goal like cleaning the room in this period of time. Yes. And then comes your utility based agent. So in this topics, utility based agent, so they are used in some kind of applications. Okay, so like the previous models, they also consider the previous state and the present state, and they continuously analyze on that. Okay, and similar like your YouTube software or Facebook, so these things use this kind of utility based agent. Okay, so it perceives the environment or perceives the data, and it finds what kind of things are happening, and it finds the optimal thing that can be applied such that your end user is feeling comfort. Okay, so based on that comfortness, you are giving the command for the actuators to do some particular task. Okay, so this kind of agents are applicable to your not only your hardware application but also for your software application also. Okay, and the last agent, it is your learning agent. So in a learning agent, you don't define some kind of control flow, sequence flow algorithms. Okay, so this kind of learning agent learns from the previous task or previous corrections or previous error that it has performed. Okay, it has some feedback loops. Okay, so whenever it sends some environment and it does some action, it once again validates that whether it is right or wrong, and if it is wrong, it is going to correct that. Okay, it's like a self-learning process. Okay, so this comes under your learning agent, where for your learning agent I can give the same example for your as a autonomous car and robotics. So where we are able to continuously learn. So for example, you can just for this kind of application or this learning agent, you can just visualize your developing stage. Okay, as a human, you try to visualize your past. So when you are at the age of 1 or 2, where you are at childhood, yes, so you are at the stage where you doesn't know about your environment. Okay, So it doesn't know about your house. You know only your mother's face, right? So at this time, you are just studying about your environment. Okay, so whatever new sound or whatever the different kind of pictures you see, you are analyzing on that. Okay, you are seeing, and even you are at those time you are just doing some replications. Okay, so whenever your mother speaks to you, you just speaks the same words. Okay, that's how you learn to speak. Okay, either your parents or relatives are teaching you how to speak. Okay, and they define how to call an object and how to speak with a particular person. Okay, so based on the different cultures of a human being, so different way of teaching it is given for the childhood stages. Yes, so you are under the learning stages, and after a certain period you are entering the school stage. Okay, so where you will be learning about your physics, chemistry and all the technical things, whatever. Okay, so from that you are acquiring knowledge, okay, which doesn't provided by your family or relative. Okay, you are acquiring different kind of knowledge, a technical perspective. Okay, so you are able to do some mathematical calculations and you are able to think related to that specific scientific topic. Yes, and based on that errors or kind of mistakes you do in the childhood stages, you are able to recover it. Okay, so whenever we do some different kind of applications, or whenever we try to implement a new kind of activity like cycling. Okay, whenever a person tries cycling, at the beginning stage he will fall down. Okay, at some instance he will just fall down. Okay, so after falling down he is learning from that, so how to properly use that particular thing. Okay, this is applicable not only for a human being but also for a AI application, that is an autonomous AI application or autonomous AI robot. Okay, so at the age of 10 to 12 you are under this learning process where you are continuously learning from the errors, from the mistakes. Okay, and after the age of 13 or 14, so now you are able to, now you are having the knowledge of your environment. Okay, of your social culture, and you have know some more kind of technologies. Okay, so after getting these kind of knowledges, now you are just defining your own set of behavior. Okay, where your character or behavior you are developing. Okay, so you know that different persons are having different kind of characters. Okay, they are not all identical. So why they are not identical? This is because their learning and their way of sensing or their way of perception the environment is different. Okay, so that's why each human has different kind of characters. Okay, one may be a rude one, or a normal person, or a very angry full person. Okay, so different kind of characters are evolved based on the environment and how you visualize that environment. That is important. Yes, and after that you are going to set your own rules. Okay, you are setting your own rules and you are only following that. Okay, and at the age of 17 or 18, whenever our parents say some kind of actions to be performed, we are not performing some of the actions, we perform only certain. Okay, we are saying that we cannot do that. Okay, why? Because we are able to think, we are thinking in that stage, and we are trying to make some decisions. Okay, at the initial stage, at the age of 17 or 18, there are chances that we do some wrong decisions. Okay, and by learning from that, we are trying to take some good decisions in our life. Yes, so whenever you move from your college or from your school to college, you take decision on what kind of course you have to take. Yes, so at this stage you are taking some decision, and you are still learning on that decision, particular decision, and you are validating yourself whether you are performing the right way. Okay, are you satisfied with your work, and you are enhancing in each stages. Okay, so now you can just visualize the same thing in your AI robotics also. So nowadays the humanoid robots which we create, so it is like similar like your childhood. Okay, at the beginning stage it is similar like your childhood stage of a normal human child. Okay, it doesn't know about the environment, it doesn't know about humans. Okay, it has some eyes and other kind of sensors to perceive some kind of environment, okay, but it doesn't know what kind of object is located around it. So as a teacher or learner, we will teach that robot, okay, in different kind of environment. Okay, we will teach some of the we will just provide the knowledge of the human to that robot. So how a human being will act and how will react, okay, and what are the objects that are available in the surroundings. So we will let's teaching, okay, and after that similarly how we frame our own set of rules, or we have our own set of characters, okay. So these robots are also able to develop their own learning algorithm, okay. They have their own kind of execution steps. They create their own based on their perception, okay. Even for a simple maze solving puzzle, the robot learns from that, okay. So at the first time it may not able to solve that puzzle, okay. It tries once again, okay. It may again failure, so it tries the third time. So now it is able to solve the puzzle in a most maximum time, okay. And when it tries the next time, it completes the puzzle in a lesser time than the comparatively your existing one, okay. By performing the same task 5 or 6 times more, the robot is now it is able to optimally do that particular work, okay. This is because your robot is continuously learning. If this was a conventional machine, then it will do the same kind of puzzle solving activity with the same number, with the same amount of time. Understood? So this is how your learning agent it is very much important for your AI application, okay. So actually we have seen what is an agent and what are the agents that are available for a human robotics softwares. Yes, so whatever that senses and do some alter the environment, we call it as an agent. Okay, so we have peers representation, so which is useful for analyzing some of the AI applications. So peers representation, it is nothing but performance measure, environment, actuators, sensors, okay. So for a single application with this representation, we are able to classify that particular performance of that particular application, and that environment which is going to perform that, and the actuators what it is used, and sensors which is used for sensing that particular environment, okay. So we will see multiple examples in this representation format. So now we will just consider this self-driving cars, okay. So this self-driving cars, as I said, this is an example of your autonomous or AI based application, yes. So I will just specify this application in a PS representation format. So now you can see that I have just classified the performance, environment, actuators and sensors what it is used in that particular AI application. So with this kind of representation, I am able to distinguish, or I am able to identify what kind of things this application is going to do, okay. What are all the things it is used, okay. So this kind of representation makes it easy for analyzing a particular application, yes. So now in this autonomous car, you can see that performance is nothing but, so how much safety it can provide us, okay. So how much safety it is providing by the self-driving cars, and the environment, it is nothing but the location or the area where your self-driving cars are actually going to be implemented, yes. And your actuators is nothing but the things that make your car in a movement, like your steering, accelerators, brake, engine, okay. So everything comes under this actuator part, and then comes your sensor, where we have camera, GPS, speedometer, odometer, okay. Odometer is nothing but we are sensing the wheel movement, Okay, we are sensing the number of steps that wheel has rotated. Okay, with that we are able to locate the amount of distance that a car has moved, and with the help of odometer we are able to locate the post or the position of that car. Okay, odometer is a simple combination of a gyroscope sensor with your encoder. Okay, this two combination will actually we call it as a odometer. Okay, so from the gyroscope sensor we are able to define the exact position or the pose of your car, and from the encoder we are able to get the distance traveled by the particular vehicle. Okay, and the speedometer, accelerometer, these things you know what they will do. And these two examples are similar like your previous one. So in the first example we are taking a medical diagnosis kit. Okay, so what is the performance measure for that kit? So it is able to whether the patient is healthy or not, whether he is affected by some certain disease. So that's his performance, how accurate it is going to predict, or how accurate it is going to say the result. And also the cost of implementation, that is an important thing in your kind of AI application. So even though your AI is more advanced, you must have a rule that it must reduce the cost of implementation. Okay, with the help of the cost minimal only we are able to provide a more sophisticated technology. Okay, with the high level cost you are not able to implement in real time. Yes, so minimizing a cost is an important measure when you develop some kind of AI applications. Okay, and the environment which is going to work, this kind of medical kits are used in hospitals or other biomedical labs. Okay, they are used by some of the professionals. And what are the actuators in that medical diagnosis kit? Some of the chemicals you have been placed in that kit. Yes, so these lack as some kind of actuators and sensors. So basically the keyboards and some kind of manual operations will be your sensors. Okay, you are just going to select what kind of test has to be performed in that particular sample. Okay, and and the other example is your part picking robot. Whereas for part picking robot the performance measure is nothing but how accurately and what is the percentage of correct placing of the object in the correct position or the correct bin. So that's your performance, how accurately and how correctly it performs the same task. So where you will be using this kind of part picking robots? So you will be using this kind of robots in industries where a long conveyor belt is used, or where your products are moved in a conveyor belt. So whenever you create some products or some kind of things, your prepared product will be moved in a conveyor belt, and you have some picking robot which has some kind of cameras and other sensors. So from that it identifies that each product is valid or it is a defect. Okay, so based on the defectness, so it is able to identify the false product, and it is able to pick that product alone, and it is going to place or put it in a location. Okay, so this is how your part picking robot works. So what are the actuators we use for that? We use joint arms and okay, and some kind of DC motors, and with encoders we use for this kind of particular positional picking. Okay, and as sensors, as I said, we use cameras and other joint angle sensors for sensing that particular angle of your robotic hand. Okay, so now we enter the platforms that are available for our AI application. So in the previous topics we have seen what is an AI and how it is actually performing, and what is data, and what are the most of the subtopics in your AI. Okay, and what are the different types of agents, and what are the different types of AI we are having. So these are some of the basic terms in your AI application. Okay, so now we will see some of the platforms which we use for creating an application of AI. Okay, so as I said, AI, it is a complete set of your deep learning, machine learning, robotics, analytics, and visualization. Okay, so multiple, it has multiple subsets. I can say like that. It has multiple subsets. Okay, where each subject or each subset, it is a specific technology. Like IoT is a specific technology. Deep learning, it is a other technology. Okay, so your AI is a comprising all this technology together for making a sophisticated, highly developed product. Okay, highly autonomous product. So what are the platforms in your AI? So you must know what different kinds of platforms we have. Okay, so I've just listed some of the mostly used in Google platforms and cloud for our AI application. So at the first point, we are having the Google AI platform, which offers a wonderful platform for creating some of the AI applications. Okay, and the next one is your TensorFlow. So most probably for creating some good projects, we use TensorFlow. So TensorFlow adds you know that for Arduino projects we use it Arduino IDE. Okay, so why we are using that IDE? It is famous why, because it has larger community support. So whenever you face some kind of errors or difficulties in implementing certain projects, you can just ask in that particular community on that particular topic. Okay, so similar like Arduino IDE, your TensorFlow also has a larger community support, and which they provide multiple libraries for your projects. Okay, so they have multiple libraries for implementing certain algorithms like your CNN, which is convolutional neural network, and fast that is feed forward neural networks. Okay, and regional convolutional neural network. So multiple neural networks, you have different kind of packages in your TensorFlow. And similarly, your Microsoft Azure, it is the other most used platform for creating an application, and most probably we use this kind of Azure and IoT ThinkSpeak as a cloud service for handling huge amount of data set. Okay, so as I said, in AI application we handle huge amount of data set. So without data set, your AI application is nothing, right? So what the dataset actually contains, that is very much important, right? So your dataset contains some of the images or that kind of values. Okay, so if suppose it is going to predict about some quality of a product, okay, then it has to be the dataset has to contain some of the composition ingredients that the particular product has, and the quality of the particular product based on the particular combination of ingredients. Okay, so for different level of ingredients, so what is the quality? Okay, so that will be our data set, and from that we will train a model. Okay, and we will use that model for testing in real time quality of the particular product. So by finding the based on the composition of that particular ingredients, so we are able to detect the quality of that particular product. Okay, so this is how your dataset will be useful. So when I say we are using dataset, we will be providing a huge amount of data for a simple cat dog classification, which you have seen in most of the some basic tutorials. So where they will be performing like a finding, you will be just giving an image, and from that input image, it will be finding whether that image is a cat or a dog, or it is some other images. Okay, so this kind of application requires huge amount of data, like 10,000 to 50,000 images are required for the simple application. Okay, so if I just I already given an example on the industrial application of AC manufacturing, right? So for manufacturer like industries, okay, they are producing multiple products, and multiple products are sending multiple datas. Okay, you try to imagine how much data are got received by the particular industry. Okay, if that industry wants to manipulate all this kind of data, they have to install some servers which might be in the size of a 3-story building, like a flat. Okay, a 3-floor flat. So that much huge amount of space is required, okay, for storing that much of data and for computing that. Your normal basic AI application, as I said, that dog or cat classification, with the help of our normal computers we are able to run that particular application. But when you are handling like an industrial project, okay, then our normal computers cannot work on that. Okay, our GPU doesn't support that. Okay, you want to have multiple or more number of GPU, okay, with higher number computational power. Okay, so we need in terabytes number. Okay, so our gigabytes level are not enough. We need in terabytes. Okay, so the speed of the computation has to be in terabytes or tetrabytes. Okay, so for that higher level of computation, we require some of the cloud services that are offered by the third-party softwares. I can say like a Microsoft Azure and Amazon Web Services. So they are some of the third-party cloud services. So they have huge cloud storage. Okay, they have different cloud centers in multiple locations of different globe or different countries. Okay, so they provide a service for the industries which is using some of the smart automation techniques, such that they allow the industries to store their particular data in their cloud, and they also can process their data in that, and they can find the useful information from the data. Okay, they can use their cloud service by paying some amount monthly or yearly. Okay, so this kind of cloud services are very much useful for implementing this kind of AI application. So without these cloud services, you cannot imagine implementing AI based applications in real time. Okay, even for a simple project, you can just give a demo, that's it. You cannot implement a huge project in real time. So this cloud services also play a major role in determining or in the real time implementation of the AI. So as I said, Google AI platform is the best one. So why it is best is that, so it has some of the benefits, and it also has some features like so it is a cloud-based machine learning system, and it offers some security for your application. Okay, and also it supports multiple number of packages that we are currently using. Even you are having a platform called Google Colab, where you can just run your model or CNN or deep learning or machine learning model. You can run on it, and you can create some projects in the Google Colab itself. You don't need to download some particular platform. Okay, so you don't need to download a software or a software packages. Okay, instead of downloading that, you can just directly use it in Google Colab. So as it is Google Colab, so whatever the program you enter, it is directly stored in the cloud base. Okay, so there is no need for storing it in your desktop or somewhere. Okay, it directly gets stored in the cloud base, and whatever the computations are done in the cloud. Okay, but that kind of cloud base will have some limited resources. Okay, they will not provide a huge amount of resources for your applications. So since it is an open source, they provide only a limited source of resources for that open source kind of applications. Okay, so these are some of the ratings for your Google AI platform. So which is a rating like a 9.5 well compared to the other platforms. Okay, so the rating is very much higher because of the multiple support for different kind of libraries. That's very much important. And next comes your TensorFlow. I've already said that your TensorFlow has large community support, and it is also has some kind of cloud-based storage. You can also use that, but as a package itself, we are able to run in multiple softwares like your Anaconda, Navigator, or Python. Ideally, even we are able to run that TensorFlow. We are able to import a particular TensorFlow package, and we are able to run that in a particular standalone systems. That is very much important. So when you are creating some of the final projects, when you just want to create some of the standalone systems that which doesn't require some of the general purpose computers, so in that kind of thing we can use some Raspberry Pi or some other single board computers which is very much compact. Okay, in that we can download this TensorFlow package and we can run our application as a standalone without any kind of interfaces. Okay, and the rating for this package is around 9.4, and this kind of packages it is more useful in implementing deep neural and machine learning algorithms. Okay, and as I said, Microsoft Azure, so your TensorFlow and Google AI platform are very much useful for creating some of the or implementing some of the learning algorithms, whereas your Microsoft Azure is used by this kind of different kind of features. Okay, they are used by different kind of technologies like your IoT or for e-commerce, for a website, okay, or for marketing, okay, or for storing some of the results or some of the prediction analysis that were done on the dataset. So your Microsoft Azure, it actually provides some cloud services. Okay, other than implementation of different algorithm, it provides more on cloud services. Okay, so when you want to use some of the cloud services, you can try for Microsoft Azure or IoT ThinkSpeak. Okay, you have multiple cloud sectors. So what is another benefit of this Microsoft Azure is that it supports multiple operating system. So if you want to run in Windows, you can just use that. Or if you want different kind of framework, okay, like we are using some .NET or whatever the framework, so you're able to, it also supports different kind of frameworks. Okay, that was the major advantage of your cloud-based services. And this is a Watson Studio, so which is also used for deep learning integration, and where you can implement multiple architectures of your deep learning modules. So when I say deep learning, I have previously said some of the algorithms we regularly use. So in that algorithms we have different kind of architectures like mobile nets, okay, PGG16. Like in mobile nets itself, we are having around 6 to 7 types of architectures. Okay, so for testing or for kind of implementing that architectures, we are able to use this kind of Watson Studio softwares. Okay, this application, it is mainly focusing on your deep neural networks. Okay, so when you want to do something on deep neural networks in depth, okay, so then you can use this kind of Watson Studio applications. And this is the exact rating for your Watson Studio. And so with this we are able to visualize, or I am able to cover the topics of the basic things of your AI types of agent. Okay, so now I will just show you how to train a model. So I will show you the basic code on training a model, so you'll get an idea how we are training and what we are doing actually. Okay, so I'm not going in depth with the code. Okay, so I'm just going to randomly say what this code is going to do. Okay, instead of focusing on the syntax of the code, I will say what this code actually performs. Okay, so we will see that. So just a minute. So I think now you are able to visualize the code here. So I am using Google Collaboratory. So I have discussed that it's an open source platform for running some kind of deep learning networks. So the code which we are, or the algorithm which we are using in this code is your CNN, convolutional neural network. So just give a brief intro on your convolutional neural network. So a convolutional neural network, it consists of three types of layers. Okay, an input layer, an hidden layer, and an output layer. Okay, so basically you will be providing the input images. Okay, so these kind of CNN networks are very much useful for image processing. Okay, so I'll be giving some input images in the input layer. Okay, and I'll be extracting some of the features I want from that images. Okay, so that kind of extraction are done in the hidden layers. Okay, and after that so after each hidden layer we are reducing the sample size of the input image such that only the exact features are transferred through the next layer. So after multiple number of hidden layers, so at the final end of the output layer we are able to provide a single dimensional matrix. So the ultimate aim of your convolutional neural network is that, so at each hidden layer you are multiplying a convolutional filter. Okay, a convolutional filter is nothing but it is a kind of small matrix. It can be 3 cross 3 or 5 cross 5. So that has some different number of weightages. Okay, in integers. So that kind of filter, it is multiplied with your input image array. Okay, when I give a image as an input, so the image, it is automatically converted, or the system takes the pixels of that images only. Okay, so each color has its own pixel value, right? So that kind of pixels are in a matrix like format, and that matrix like format, it is given as an input to the hidden layer. So now your convolutional filter is multiplied with that input matrix. Okay, and after that we are getting some result, right? So that result, it is then followed by, we have some activation function. Okay, so in convolutional neural network we have allocated different neurons. Okay, so whenever our image size is like 10 cross 10 pixel, so which is 100 cells. Okay, we have allocated neurons for specific part of the pixel. For example, I am allocating a neuron for 25 pixels, or for 25 cells I am allocating a single neuron. Okay, so such that for 100 cells I am allocating 4 neurons. Okay, for analyzing that image. Okay, so I cannot directly go and activate these 4 neurons. Okay, I can activate only 1 neuron at a time. Okay, so for that activation purpose we use some activation function. Okay, that function can be a linear or a sigmoid function or an RLD function. Okay, so that that is used for activating that particular neuron when a particular feature has been extracted. Okay, so in a hidden layer you have a convolution step followed by the activation step, and at last you have a step called maximum pooling. Okay, after the extraction of feature and after the activation of that particular neuron, you are going to reduce that particular sample size. Okay, if it is in a 32 cross 32, you are just going to reduce that sample size into a 16 cross 6. Okay, so these three segments are happening in a single hidden layer. Okay, so like this we are having multiple hidden layers. Okay, so in each hidden layer your data is multiplied with a convolution filter. Okay, and it is resized. So at last, and the output layer, so you will be getting a matrix in the structure of very much small. It will be around 4 cross 4 something. Okay, so at that small size of matrix you are able to get only the important features that are required. Okay, and then we are going to convert that to 4 cross 4 matrix into a single dimensional matrix which contains only a single column. Okay, and that single column will contain only the weightage of that particular feature, right? So this is how we extract that particular feature from that model and we analyze with the trained model. Okay, we have some data set, right? So from that we have some trained model, and with that weightage we will be comparing the weightage of that input image, and based on the matching, okay, based on the similarity of that weightage, we define or we predict that this image belongs to this kind of classes or this kind of category. Okay, so this is done. These are some of the basic operations that are involved in this convolutional neural network. Okay, so I thought to give some intro on this CNN. So I'll just give a brief on it. So now we'll just move inside this code, what this code is performing. I'll just say one by one. So I know it is a little bit difficult. So without knowing some of the basic syntax, saying this code like it looks like a difficult one, but it is mostly a easy code. Okay, you just refer some of the basic syntaxes. So I have given the basic working of your CNN, right? So after this webinar, you can just go and browse it for some of the basic syntax so that you know how they work. Okay, it is very much easier. Okay. So in this Google Colab, now I have uploaded my code. So what is this code is that it is a classification code where by giving some input images, it is going to classify whether it is a dog or a frog. So you can see the class name here, right? So we are able to identify these types of objects in the particular image. Okay, so if I'm just giving an input image, and if that image contains a dog face, then it finds that dog face and it predicts it, or it gives output like this input image contains dog face. Okay, and similarly, if these kind of multiple objects are present, then it detects that. Okay, if that contains if that doesn't contains the objects that are related or that are defined here, then it is going to show some kind of output. Okay, so like this image it is not relevant, okay, for this kind of trained model. Yes, so what we are at the first step, we are importing the TensorFlow package. I say no, TensorFlow is a package so which can be imported in different kind of softwares. Okay, so similarly in Google Colab, I am importing this TensorFlow package, and from the TensorFlow I am using Keras. So Keras is very much useful for defining your dataset and creating some hidden layers. Okay, so for that I am using Keras, which is a sub package of your TensorFlow. And at last I am using matplot library, which is a library for plotting some of the graph values. Okay, so whenever you do some algorithm, or whenever you do some of the calculations in your algorithm for finding out its accuracy or a percentage of its predictfulness, so we use this kind of graph plotting systems, right? So now after importing some of the basic packages we require, we are just going to upload the dataset. That is the first important step. Okay, uploading the dataset is the first application of your deep neural network. So I'm just going to upload this dataset. So datasets are even provided by some other agencies like Minset and CIFAR and COCO, and there are many number of agencies are available providing your dataset for particular application. So for this classification of these 10 objects, CIFAR gives a dataset for this application. Okay, so I'm directly loading that particular dataset by this link. Okay, so without downloading that particular dataset, I'm able to directly upload it. Okay, from the online URL itself. Okay, so for that I'm just giving the command as dataset.cifar10.load data. Okay, so this load data just loads the dataset from the website, and here I'm using the split function like trained images and test images. So whenever we are creating some model, or I said that in a AI application we need some data set, so and we will just train a model, right? So to train a model, after training I want to validate it. Okay, how accurate I have trained that model, right? That is very much important. So whenever we study some of the technical concept, our university keeps some test, okay, for validating us. So similarly we have to test this model for validating. So we are splitting that given dataset into two categories, training and testing. If my dataset, now this CIFAR dataset contains around 50,000 images. Okay, so 1,000 images for each classes. Okay, so it contains around 50,000 images. Sorry, not 1,000 images, it is above 1,000 images for each class, but overall it contains 50,000 images. So in which 40,000 images are separated for training, and the 10% images are the remaining 10,000 images are segregated for testing. So this split function randomly splits the data set. Okay, so there is no predefined of separation, it randomly splits it. Okay, so after splitting, now we are just randomizing the training and testing images, and after that we are just providing the class name that are available in this data set. So at the beginning I'm just printing some of the images that are available in my data set. Okay, from each class I am just printing 1 or 2 images that are available in the data set. Okay, so for that only I am just defining the class name. I am just giving all the 10 classes that are inside the data set, and after that I am using the matplot library for visualizing that images in the data set. So I am using the command called plot figure. Okay, so after that I am using a for loop for printing the images in multiple classes. Okay, I am iterating over each class name and I am printing some 1 or 2 images in that. Okay, so now for this example I am just going to print 25 images. Okay, so you can see at the bottom, so these are the images that are present in the data set, that in the CIFAR data set. So you can just visualize that it is a frog image and a truck. So you are able to visualize, okay, or you are able to recognize what is the image, but it is not in a clear cut, right? So it is in a blur stage. Okay, so even though these images are very much blur, so whatever the most important features are required for classification of a particular object, so this kind of images are enough. Okay, even though they look blur, they contain all the features for the respective classification process. Okay, so now this is our model, and after that now using the convolution neural network we are going to create some of the hidden layers. Okay, so for creating I am using the model keyword. Okay, so for I have already said that our convolution layer consists of a convolution filter followed with the activation function, and after that we are having the maximum pooling, right? So you can see here we are using the convolution filter here, convolution 2D, that refers that we are going to multiply a 2D convolution filter with that, and our size of the filter is 3 cross 3. Okay, we are giving the size, and I mentioned the activation function as RELU. Okay, and the input image or the input future image, okay, in the data set it has a size of 32 cross 32. Okay, so when you just create some data set, you can you know that particular size of that pixels. Okay, so next I am using this maximum pooling followed by, so after convolution and after the activation of that particular hidden layer, so at last your maximum pooling reduces that particular size. Okay, so I am using 3 layers, I am implementing 3 hidden layers. Okay, so that you can see that I have used 3 convolution filters followed by maximum pooling. Okay, so my ultimate aim is that I'm just going to transfer the features to the end of the output layer. At the end of the output layer I want only the features. Okay, so for that I'm just convoluting and reducing the size of that particular image. So you can see at the output so you can see the output in the below code. So this is the output of this particular code that I explained here. So you can see that at the starting stage and the first stage of convolution the size is 30 cross 30. Okay, after maximum pooling it is reduced to 15 cross 15. So I said no, in maximum pooling your sizes get reduced. Okay, so after again multiplying with the convolution 2D filter, the size it is 13 cross 13, then after maximum pooling it is again reduced to 6 cross 6. Okay, and after again doing some convolution your size it is reduced to 4 cross 4. So in these 3 layers, so my input is around 30 cross 30 or 32 cross 32, right? So at the end I'm just getting a size of 4 cross 4. Okay, and but you can see the parameters or the features. So at the size of 32 cross 32 it has considered the features of 896, but at traveling the each layer your number of features detected are very much higher. So this says that only the features are contained in this particular matrix 4 cross 4. Okay, so at end I'm just printing the number of parameters that are detected. Okay, and after that, so these are your hidden layers. Okay, and in this stage, so we are I say that in the output layer we'll be converting that 2D array of matrix which is in 4 plus 4 in a single dimensional matrix, right? So using this flatten function, we are converting into a single dimensional function, okay? And we are using the dense function for classifying that weightages, okay, of that particular set of classes, right? And after that I am using this keyword called model.summary, so it again prints the summary of the trained model. So what are the input sizes and what is the ultimate reduced size and what is the ultimate total parameters it has found, okay, or the number of features it has present in that particular flattened layer, okay. So at the end of the trained model we have around 122 parameters, right? So now we have confidently we are able to train a model in a CNN network, right? So now I'm just going to test the same model with the test data, okay. I'm just going to compile the test data with the trained model, okay. So I'm just running some iterations for 10 times. So this epochs determines the number of iterations, okay. I'm using the training images as well as for validation I'm using the test images, okay. And I'm just validating my trained model. So you can see in this stage is that at each training, our accuracy it is increasing. So you can see here we are printing the accuracy and the losses. So the losses determine the deviation from the prediction error, okay. This is nothing but your error rate, okay. So at each iteration you can see that our model is getting trained, okay, and at last we are able to achieve accuracy of around 85 to 90%. Whenever you train a model we have to know our accuracy and what is the losses in our model, okay. So this is very much important. So whenever you train a model we have to know the ultimate accuracy of it. So with that only we are able to compare with different kind of models and different kind of algorithms in our neural networks. Okay, so now I am able to define a model in CNN and I am able to train a model and the ultimate accuracy I got was 80%. So still I want to run this I want to just run this model for nearly 20 to 30 iterations for getting a higher accuracy of around 95%. But for time's sake I am just running an iteration of 10, okay. Why? Because it takes some around 1 or 2 minutes for running the full code. So I have just already ran that code before entering the class. So still we can enhance our accuracy, okay. So at last I'm just going to print this accuracy and the value accuracy is nothing but the deviation, okay, or the error rate, right? So in the graph you can see that, so at initial our error rate is maximum, it is higher than our accuracy, and after that after multiple trainings you can see that our accuracy is very much higher and our error rate is reduced, okay. And at last we are just going to print the overall accuracy of our trained model. So still as I said, this trained model has to be run with more number of iterations, so for increasing the accuracy, okay. So this is how you train a model, okay. As an example I have used here a CNN network. So like this we can use multiple networks using this or you can implement multiple TensorFlow packages, okay. Instead of CNN you can just try with a regional concurrent neural network or a feed forward, or even you can go for a or even you can just use some other learning algorithms, okay. So this is an algorithm for kind of image processing, okay. So we use CNN for vision based projects, okay. As I said, like we use machine vision for tracking some of the objects, right? So for the tracking we use this kind of CNN networks for more accurate tracking. other than your previous segmentation analysis. So what are the previous algorithms you have? So it provides you more accuracy, okay, when compared to your previous models. So today I have just shown how to train a model, or how we are training a model using a CNN network. Okay, so we are just creating some data set. We are splitting the data set into a testing and training, and as well as we are training a model using the CNN algorithm, and after training we are testing our trained model by giving some test images and validating our accuracy of that trained model. Okay, so this is the exact step of your learning process in your deep learning, okay, which is a subset of your AI application. And also we are developing multiple robots under this AI projects. So where we develop robots for autonomous navigation for indoor environment, where we have different kind of structures like two-wheel robots or four-wheel robots, okay, for detection of fire, and for fire detection we are autonomously navigating towards that fire occurred area. So we have implemented this kind of deep learning techniques for different applications of robotics. Okay, we are doing multiple projects on these kind of areas. So today I have just shared some of the basic topics and how we are training some of the models in the CNN. So I wish this could be a useful thing for you. So we come back to the slides. So we have seen about the robotics and what kind of different kind of platforms we are having. So for what kind of applications which platform can be used. Okay, so why we are using some of the cloud platform, right? And we have also seen how to what is CNN. I have just given an intro on CNN, how it works, and some of the basic code I have just shown you. Okay, how to train a model on CNN. So I've just given an introduction to this concept. Okay, so you have to explore more on this. Okay, as I said, AI is blooming now, so you have to know more kind of knowledge. You have to acquire more knowledge on this particular topic. So you try to explore and you try to do some more projects. You have many kind of basic tutorial projects in your internet, where you can just simply run it on your Google Colab. Okay, even if your desktop is on a very light version, so you can just run on it on a Google Colab. Okay, and you can just increase your knowledge on your AI concept. So whenever you move out to industry, so nowadays we are actually, most of the industries are nowadays involved in data collection and data analysis, right? So it is important that you have to know some of the deep learning networks and how these algorithms are working. Okay, at least the working of the certain algorithms must be known by you, right? So you try to explore more on this. So I have just given an intro on different kind of things that are required for your AI. Okay, now it's your part on learning on this, and we are also providing some courses on this kind of deep learning and machine learning things. So I wish that you utilize and you develop your knowledge on this particular topic. Okay. So I conclude this webinar that whatever the topics we have seen from the start to the end of the session. Okay, so we have seen the introduction about the artificial intelligence, AI, and different types of AI agents like simple agent model, and goal-based agents, and utility-based agents, and learning agents, and how your robotics are learning. So for that I just given an example how humans learn from their childhood, right? So I just given examples related to all kind of things, all kind of different types of AI. I think those examples are useful for you for getting understand the concept. And also we have discussed some of the platforms, TensorFlow packages, Google AI platform. So for analyzing, and we have done analysis on those platforms. So what can be done, what can be used for what kind of application. And we have just shown you a training model on your CNN network, right? So we have just given some of the boost ups for creating a curiosity for you for learning on AI application. Yes. So I wish all the best for you for learning and for getting a deep knowledge in this AI topic. So I thank everyone for attending this webinar, and if you have any kind of doubts, you can just put it in the top chat box, so I can just reply it. Or if you have any kind of feedbacks, you can give it in the chat box. So I've taken for around 2 hours. So if you have any kind of doubts, any clarity or you need to get, you can just ask in the chat box. So if you have any doubts, you can just ask me in the chat box, so I'll be able to reply to that. So some of them are asked that searching a product in Flipkart randomly changes cost of them. Why? So whatever the prices that is shown in the some kind of product selling websites, so they are changeable, and that's because when you're using some of your account, so they know what kind of products you are searching and what kind of offers will suit you. Okay, so even some of them are giving some of the offers, right, like 50% off, 80% off. So that's all depend on your kind of login activity. Okay, so when you use some kind of cognitive tab, then your user login cannot be used there. Okay, so there in that if you open a similar same web page, then there you can see different type of offer or different kind of rates. That differentiability will be happening there. Okay. As I said, no, it is all related to data only. So it is making you to buy some products. So it is just like a negotiation that is done between you and the server. The ultimate aim of the thing is that make it to buy. Okay. So you have any other doubts regarding this AI topic or any kind of projects? Or on the code that we have done previous. If you have any queries, you can just put in the chat box. So one of us has asked what's the difference between machine and the robots. Yeah, when I say a machine, okay, so a machine it is for a particular task, and it requires a machine is nothing but it is just reducing your effort on the particular task. Okay, so even a car engine, it is a kind of machine only. Okay, so it is producing, it is doing some task of converting some energy, okay, such that you are converting your fuel energy into a movement, right, mechanical energy, right? So machines are able to convert or can do some efforts, or it can put some efforts with reduced computation, okay, than your human. Whereas a robot is also a machine, but what is the difference, what is the exact difference between your robot and machine is that your robots are defined for real-time application in a product level. Okay, so your robots they are useful for creating a specific task or for involving in creation of a particular machine. Okay, you can use robots for creating a machine itself, okay, but you cannot use machines, okay, you can use machine for creating some products or for a particular specific part of that particular product. Okay, whereas a robot is the ultimate product, end product for any other application. So the ultimate difference between your machine learning and deep learning is that, so your machine learning it does some analysis on the data set which are going to provide. Okay, for stock market analysis, you will be providing the previous past history of your stock market, and from that it is going to do some analysis and it is going to predict the future level of the stock market. Okay, so for prediction or for analysis on kind of some kind of data like stock markets, okay, or kind of review ratings, something, okay, so we use machine learning there. So where we use deep learning is that where continuous learning of that particular algorithm is required. Okay, so as I said, when you do some image classification technique, okay, so when you are just going to identify a truck from other vehicles, so you can use deep learning, okay, where different types of trucks and different forms of trucks are available. Even though you provide some of the data set, sometimes there can be an exceptional cases of that particular trucks, and even though your deep learning might fail at the 1 or 2 times, so at the 3rd or 4th times it is able to recollect that and it is able to provide you a more accurate model. Okay, it continuously learns actually. So that was the exact difference from a machine and deep learning. Your deep learning model, it will be continuously learning one. Okay guys, so I thank everyone for attending this webinar. So I think I have conveyed most of the information that I have thought to deliver in this webinar, and I feel that it may be a useful one for you, and thank you everyone for attending this. I thank everyone. Yeah, the feedback link will be shared later.